This is a video to explain how you can find psychometric information about a survey or a test. We'll start with this example, the Community College Survey of Student Engagement, CCSE, and here we have a link that we can go, and there is the survey, right? So, okay, it looks legit, right? We can see that this is a Scantron type survey, right? It was used to fill out with paper pencil and then scan it in. And, this is the actual survey, right? But what we're interested in, and this is good information to look at, right? So if you determine if you want to use it for your survey, this is some information that you definitely want to see. You can see the Likert scales here. You can see the different items. And you can also look at what might be the things to include or exclude, right? Now, what you can imagine is behind these individual questions, there are what we call scales or those latent constructs that we measure. So how would you find more information about this? One simple thing is to just do a Google search, right? So I Googled for this. Then I went into here about the survey. We could go look at this. And now you see here there's a bunch of information about it. Just the instrument, etc. There's additional items or special focus items, right? Especially these big surveys that are conducted every year. Some years they add special items. And you could see maybe there's something that you're interested in particular. But we're going to look at this here, the CSSA psychometric paper. And when we click on this, we get to this paper here, which turns out to be exactly what we wanted. Dimension of student engagement in American community colleges, using community college student report and research and practice. Okay. Now note this was submitted for publication. We could go check and see has it actually been published, because the actual publication is what matters, not just submitting it. So here, community college, widely used instrument. Again, even if it's widely used, does not mean that it's good quality, right? That's what we want to see for ourselves. And we see here, okay, this examines the reliability and validity of the instrument. Oh, perfect. That's exactly the type of document we're looking for. Confirmatory factor analysis, demonstrated factor analytical models, right? So confirmatory factor analysis is when you're trying to confirm a factor structure. You say there's 3 factors, for example, and each of these factors has the following items. Whereas in exploratory factor analysis, you don't specify a certain factoral structure. You let the factor analysis discover the structure, right? So sometimes what we do, we run an exploratory factor analysis first, and then we run a confirmatory factor analysis after. But the confirmatory factor analysis is the stricter one. And then what we can also do here, we can test for measurement invariants. So that means when we test for invariance, means that it does not vary across groups. For example, here we have the groups sex, so male and female, or we have part-time and full-time status, or year of administrations. So here they actually had 3 years, right? So it can be more than 2 groups, right? Gender, you had 2 groups, full-time status was 2 groups, but year was 3 groups. So basically this is the test. Does this structure vary across different years? So it's a plus when the structure does not vary across the different years. So then they go on to say that it has reasonable internal reliability and test-retest reliability. So internal reliability is that internal consistency. This is most of the time measured with Cronbach's alpha. And the test-retest reliability is measured oftentimes just with a correlation. So to see how well does a value correlate with itself across time. So for example, from month 1 to month 2, or year 1 to year 2, etc. And then they also look at grade point average, regressed on the latent factors, and this demonstrates a positive association. So this kind of like a validity to say, hey, these are engagement constructs, so they should relate to higher achievement. If we can see this, then that's a indicator that this is actually really measuring what we're tending to measure. Okay, so this is all fine and dandy, right, in this abstract, but we want to be a little bit more critical and actually go look at some of the numbers. By the way, this is a wonderful report, just to see it as an example. I think there's some, there's some things that we can criticize, but it's a good overview of what such a report could look like. All right, so there's a little bit of theoretical section, and then they talk about how they came up with it, right? What's the basis of this? Then they had these latent constructs. So again, latent construct, or the construct, we can't observe them, but we can measure them with different items. And here is, right, so the validity was assessed with this confirmatory factor analysis, and then we looked at different groups, etc. And the consistency within the construct was assessed using Cronbach's alpha. This is the reliability coefficient. And then Test-Retest was assessed by comparing results from individuals, repeated survey administration. So this was a correlation. The validity was assessed by regressing students' reported GPA on each of the latent constructs. So again, we could say, okay, GPA, correlation between GPA and these constructs, that's one thing. You could be a little bit critical and say, well, actually, if you're looking at student effort, there's actually other student effort scales out there. So they could have done the survey with their student effort scale plus some other student effort scale, and then looked at how well do these two correlate, right? Or maybe there's a scale that measures student laziness, and then what you would expect is that student effort should correlate negatively with student laziness. So this just as a further example how construct validity can be established. Then here the method section, right? We see participants, we see 3 years, 2003, 2004, 2005, from 103 colleges, right? In 2003, over 60,000, 2004, over 98,000, and 2005, over 140,000 responses. So huge samples. Wonderful for statisticians, right? And then we go into the measure. Here a little point to note is that they have some items are on a 7-point Likert scale, others on a 5-point. In order to really compare those two, they did a mathematical transformation so that the middle that the end was always 0 and the top always 1. So that's just so that they could compare the different scales. Then here they talk a little bit more about the sampling. Here, a stratified random cluster sample, right? Wonderful. So this is what we talked about in the earlier part of the course. They talk about some disadvantages as well, but then also here the stratification, right? They wanted to make sure that the time of the day which a class was adequately represented. And then the way they administered it, here noteworthy, they used a script, right? So that the script kind of helps that the survey administrators stay on task and don't add any potential details or information that would bias the results. Then results, the missing data. This is an important technical part. that you want to include is how did you treat the missing data. Just different ways of doing it. And here you basically give your spiel about which method you used and why you used this. So this right now this is not too relevant for us. Then the factor structure, again CFA is short for confirmatory factor analysis. And what we do is we specify the structure, right? We say these items go with the following factors, and then we model this with our data, and then we get a score for how well the data fits the model that we theoretically specified. And some of these mathematical indicators are this root mean square error approximation, RMSEA, or this RMR. Those are different coefficients. There's other indicators, and then there is here some indicators of what levels we're looking at. For example, RMSEA should be small in 0.06, RSMR small in 0.09. You know, depending who you talk to, they are offering different cutoff values. But the idea here is basically that you compare your data with the theoretical data and see how well does your model fit the data. Important here, they say, okay, we use this M+, that's a software, like you're familiar with SPSS. M+ is another statistical software. And then they talk about measurement invariants. So they looked at the three groups, 2003, 2004, 2005. They looked at male and female, looked at part-time and full-time. And then what they talk about is that there wasn't any big differences between these groups. So that means basically the structure, the factorial structure holds up across the different groups. Now, you know, if you want to be a little bit critical, you say, well, what about ethnicity or race? Did you guys look at if it works the same way for white students as it does for Latino and Latina students? Well, in this case, they hadn't, but that could be something that we could wonder about. Especially if you are looking at mainly Latino population and this survey has not been validated with Latinos, that could be an issue, or maybe it doesn't matter. It depends on content of your survey. Here, convex alpha, and then the gold standard rule of thumb is 0.70. Now, this is really interesting how they formulate it, right? They say evaluation of convex alpha showed that there was generally strong consistency in the underlying construct measured within a factor, right? Though some alpha values did not exceed the gold standard of 0.70. See table 2 for alpha values for all constructs. Okay, we'll go check that out. Then test-retest is to look at how does this work here? How stable is it across time? So therefore they looked at people that filled out the survey twice. All right, let's go look at this here. And then there's this discussion, which is fine, but we want to take a look at the numbers. First thing would be look at the different populations of the samples, right? These different samples. And what would be important is this sample representative of your population or of your sample, right? So here we have 40% male, 60% female. And then we have race, right? For example, here, if you have a large Latino population in your sample, like it's common in California, you know, this sample might be a problem, right? We have mostly white students and then quite a bit of African American, but not that many Hispanic compared to California standards. So you could say, okay, maybe this survey is not that suited for California, who knows? Then also the age distribution, maybe you have a population that's a little bit older, or maybe they're even younger, depends. Then also enrollment status, what is your distribution there? And we notice here, right? If we look at, for example, let's go to the last column, we have the 2005 sample and 2005 population, right? In the sample, we have 31% are part-time, but actually in the full-time proportion, there's 60% that are part-time, right? So even here within their own study here, they have a discrepancy between who is in the sample and who is in the population. It could potentially be a question that maybe all this stuff about student engagement is different in this sample than in the population. Okay, here the reliability. Now we have here the alpha, convex alpha, and the test-retest. And here are the latent constructs. So for example, the scale for active and collaborative learning has an alpha of 0.66, right, which is a little bit below the 0.70, and a test-retest correlation of 0.73. So if you are high or low in active and collaborative learning, tendency is low as well. Now, let's look at what has the lowest test-retest. We see that's for student services, right? So imagine that makes sense. They could fluctuate because you might use it one year quite a bit, and then next year you might use it less. Then let's look at the alpha, and so if we just use the 0.70 gold standard rule here, we can see this one is below, this one is below, this one is pretty good, this one is below, this one is pretty good. So if we look overall for the alpha, if we use the 0.70 criteria, we actually have 8 out of these 14 that are below the 0.7 value, which is not ideal. But then again, if they're really valid, that might justify to have a little bit lower reliability, right? Because as you have items that are a bit more different from each other, you pay for that by having less consistency, right? Imagine this. If I ask you 5 times almost the exact same question, yes, you better have high reliability, right? Because your answer is going to be very consistent, going to be very much the same. Now imagine as these 5 questions start becoming a little bit more different, right? You start to cover a broader area of content, and thus it's normal that the items are less consistent, right? But then there is a sweet spot where you have still enough reliability, but you also cover enough validity. And then for the validity, what they try to show is how do these factors relate to the GPA. So they describe that they regressed GPA on these factors, and so we would assume a positive interaction between these factors and GPA, and that's what they show here. That and then again they talk about the person level, so that will be the individual student's interaction with the GPA, and then they came up with a institution level coefficient, so that will be the average faculty interaction in that institution with the average GPA, and that those are these factors. And that's why you see some of these turn negative, because it's at the institutional level, so it's at the group level, which I don't think it makes that much sense, but anyways, I think here we have the GPA. We could also say that we want to look at other factors. For example, they could have used a different survey that measures faculty interaction and seen how does this faculty interaction factor relate to the other scale that measures faculty interaction. Or they could have looked for another academic preparation survey and seen how does this survey correlate with the other academic preparation survey. But this is just an example of what else would be possible with establishing validity.